Hi, everybody. So I'm here to talk to you today about what I learned making Bill, the helpful robot platypus that reads our documentation for fun. I should make this full screen. Can I do that? If I do that, am I going to end up breaking the monitor? Let's see. Oh, all right. Cool. So my name is Todd Kerpelman. I work for a company called Plaid. If you haven't heard of Plaid, it is a fintech platform that can deliver a whole bunch of solutions, whether you're trying to get like verified account and routing numbers so you can do payments, to like identifying somebody's, verifying somebody's identity for like, fraud, compliance, credit underwriting, all that stuff. The reason I bring all that up is I want to be able to expense my plane ticket out here, and a product plug seemed really nice. But also, it's a complicated product. There's sort of a lot that's going on. It's like, 8 or 9 products all in one set of APIs. There's a lot of data that gets sent across. There's a lot of nuance, a lot of similar sounding pieces of data that mean different things. Finance, just in general, is somewhat complicated. So in order to help our developers be more successful, we built Bill. This is a chatbot that's on our site today. You can try it out if you go and visit our documentation site. Up there in the search bar, in addition to searching, you can ask Bill a question, including this one that was sent to me by a coworker. I guess he's going through some stuff. But I think the interesting thing is, like, Bill was able to still accurately answer this person's question, which is crazy because it's not in our docs anywhere. I checked. But it's still able to sort of parse our docs and respond intelligently to our user's question. So let's explain, how we got here, what I learned along the way. So like many fun projects, this started off as a hackathon project. A little less than a year ago, we had a hackathon. OpenAI had just made its APIs more available to more developers. We managed to get our hands on some keys, and we're like, well, let's try making a chatbot. There were a couple blog posts at the time that sort of, helped us kind of get a sense of how we could build this thing. And so let me explain a little bit about how this works. I apologize if this is a review for some of you. You just sit back and feel smart. But for the rest of you who haven't learned this yet, this is basically sort of how a chatbot like Bill can get trained on a set of documentation. So the first thing you do is you take all of your public documentation. For us, we took our public docs, we took transcripts from our YouTube videos, we took some implementation PDF guides, some articles from our help center. You take all that content and you basically kind of break it up into little chunks that are like, a couple of paragraphs long. Once you have all those chunks of text, you then try and distill down the meaning of that text by sticking it in a point in space. And let me give you an example of what I mean here. Imagine I had sort of a 2D graph where I had like hot weather activities and cold weather activities on one axis, and things that are sort of a chore versus fun on another. You can kind of get a sense of where most of these activities would find themselves on this graph. And if we had another one like cross-country skiing, it's going to be down in this area, but it's not that much fun. It's really more work. And so you kind of have a sense of where it would go. And so that's what we did with all of our text, except instead of putting it in a 2D chart like this, we put it in like 1,500 dimensional space. It's just, really hard to draw that in Keynote, so you'll just have to imagine it. And we do this using something called an embeddings model. This is something that like OpenAI has their API called the Embeddings API. There's a number of open source embeddings models out there, but that's really all they do is they take some content, text, but also sometimes pictures or other content, and condense it down to a point in space, in many dimensional space. So once you have this giant vector, then you store all of that in a database. There are vector databases out there. We used one called Pinecone that are sort of specifically designed for storing these large vectors and also helping you find which vectors are close to each other. So we store that vector, we store the text that was originally used to generate that vector, and then some metadata like the URL and the title. So then what happens is when the user asks a question, we take that question and we run it through the same embeddings API that we used on all of our documentation, and we end up with another giant vector. We send that vector to our vector database and we say, hey, can you find us like, 4 or 5 vectors that are close to this one that we sent you? And then once you do, give us the text that's associated with all those vectors. And so what you end up with is a bunch of pieces of documentation that are probably pretty relevant to the user's question. So we can take the user's question, take that supporting material, and we send it off to our large language model, in our case, GPT-4, and say, hey, can you answer this question, based on this information? And 9 times out of 10, it can. We get a surprisingly accurate answer out of all this information, which is kind of neat. This is basically just a very simplified version of the prompt that we send in. You can see it's basically, hey, you're a chatbot. Here's the user's question. Here's some documentation that might be useful. My favorite analogy for describing all of this, by the way, is like it's less about studying for an exam and more like showing up for an open book exam where you have a magical notebook that opens up to the right page every time so you can kind of, BS your way through the exam. It's really neat. And this is basically what people are talking about when they're talking about retrieval, augmented generation, or RAG. This is, like what Ruben talked about as level 4 in the last talk, and the Gardner gentleman talked about with his diagram that was much more professional looking than mine. But that's all it is. It's like you're going to grab some relevant information and take that alongside the user's question and hopefully generate an interesting answer. So we had a working prototype, and it seemed to actually do a pretty good job. So of course the next question is like, well, okay, now do we take this prototype and build it out into a real solution, or do we buy? At the time, there were a couple of third-party solutions that were just coming online. We started looking at those. I'm not going to go into too much around this because I don't have a lot of time. And also, these are kind of the same build versus buy decisions that I think most people have to deal with. I would say right now, we did end up building. We have a solution that I think right now is probably a little better just because it is very customized. We're able to do some custom work that we maybe couldn't have done with a third party. I expect in a year, maybe 2, these third-party solutions with dedicated engineering teams will probably lap us, and then we'll switch to them. But I will say one real nice advantage of building it yourself is like you get to learn about LLMs. Like I don't think AI is going away, and being able to build something in-house is just sort of really, it's nice to have more of that knowledge, internal, so that, when there's other problems that come up that might need AI as a solution, you kind of have an idea of how you'd approach it. But of course, the flip side is like the whole like, oh yeah, I could totally build Twitter in a weekend. I mean, you can, but the amount of work it takes to take something that works as a simple prototype and productionize it, it takes a lot longer than you thought. It turns out I'm not very good at estimating time to make these things. Let's talk about setting expectations. I think these days probably most of us have a good idea of what to expect from a chatbot. Certainly a year ago we didn't. We were like, well, maybe we don't need documentation anymore because our chatbot will just tell all our users what to do. But that's not true, right? Like you definitely still need documentation. In fact, I would say having a good chatbot is highly dependent upon your having good documentation in the first place, because that's all the information that you're feeding into it. But what it can do is make your docs experience better in a few different ways. Chatbot is really good at sort of synthesizing information across different pages. So you can compare and contrast 2 different products. It can often be a better search than search. If your user doesn't know the term of the technical term of the thing that will solve their problem, but they can still describe their problem, a chatbot is often very good at saying, oh, you probably want this. I think it's really good at rephrasing generic docs for a specific use case. Developers would love it if the documentation was just like, hey, here's how to build this exact thing that you're looking to build. It's hard to do that when you're trying to create documentation for, all of your developers. But a chatbot does do a good job at sort of trying to rephrase your documentation for a specific use case, which is nice. Similarly, this will not replace your support team, but it will make their lives easier. I would say, looking at all the questions that our support team gets, most of these I still would not trust to an AI. You really want a human to be, answering things like, hey, this call seems to be broken. Is there, a bug on your side? Have them look into it, figure out maybe is something going on. However, there is this category here of like, hey, here's a question I have that's already answered in the documentation that your support team would rather not spend their time working on, because that's sort of not where I think they're most needed. And so by having a chatbot, and we actually added a chatbot in our support flow, we're able to sort of head off a lot of these questions before they make it to our support team, so they can spend their time concentrating on like the actual, I think the questions that they would rather work on, the more complex questions that really need a human. Sometimes people are surprised to hear that we use GPT-4. Because it is sort of notoriously expensive. For those of you who don't know, like OpenAI has a number of different models. 3.5 is fast and inexpensive. 4 is better, a little slower, and it's also known for it's like 20 times more expensive than 3.5. And so people are like, well, we can't use that in our solution. It's too expensive. But I would say, think about realistically how many AI calls you're actually going to make. Like we are not a company like, we don't make React, where we have like millions of developers all using our product for free. Like we have thousands or tens of thousands of developers, all of whom are or hopefully will be paying customers. So for us, it's worth the extra cost to make a chatbot that can hopefully help them be more successful. And in the grand scheme of things, like, even with the questions that we get, like we're only spending like $20 a day, $25 or something on OpenAI calls. It's not enough to break the bank. One of the trickier parts is evaluating performance. Because you can see here, we have two answers, both of which seem like they're the right answers. They're actually saying very different things, and maybe you wouldn't quite realize it unless you have deep knowledge around, Plaid's APIs and how some of these products work. So how can you figure out, whether your chatbot is actually giving you good answers or not? You might be like, well, what about, user feedback? No one ever clicks these buttons. Like we have these, the sampling size is too low to, get anything significant out of it. And I would also say sometimes people click, the wrong button for the wrong reason. Like the chatbot will give them an accurate answer, but they don't like the answer, and so they'll be like, no. Or you won't realize till after the fact that, oh, that chatbot gave me a wrong answer. There are also third-party companies out there that are starting to try and help evaluate these answers for you. They do this sort of by doing meta-analysis, like they'll look at the documentation that you sent to your chatbot and what the chatbot responded with and how much of the documentation it used. It's interesting. I haven't done a lot of exploration there. So for us, what we did was sort of our first line of defense was just to have the bot grade its own homework. So what we do is we have a series of questions that we came up with, and then sort of ideal answers, and then a set of scoring criteria that we would use to sort of score how well a chatbot might do at answering a question. And what we did is we took that set of questions and we send it over to Bill, and we're like, hey, why don't you answer this question from a user? We only send the question part, obviously. We get back an answer, and then we take that answer and we send that back to OpenAI, to GPT-4, and we say, hey, can you grade this answer based on this set of scoring criteria? And what we get back, is a score, something out of 100. Now, this kind of works as a sort of, like I said, a first line offense, but it's crude. You won't get a lot of precision out of it. There's still a bit of variability, so it's not useful for like, well, we made this tweak and things seem to be 2% better. It's more like, well, we made this tweak and nothing seems to be horribly broken. You can kind of use it for that. I would say, right now, what we're doing is like analyzing this by hand and looking at the answers that we get. Obviously, we're not looking at every answer, but we still do spot checks on sort of the questions and answers that Bill is getting. I would say, right now, like it's still getting answers, I would say 70% correct and 25% mostly correct, meaning like, yes, he's answering the question, but maybe he's missing, a little piece of information that would have helped. And then, 5% of the time, I would say he does get the answer wrong. And so obviously we want that 5% to be lower. So what do we do when Bill gets a question wrong? The first thing is generally fix the docs. Oftentimes Bill will get an answer wrong and we'll be like, well, that's ridiculous. The answer's right here in the documentation. Oh, no, wait, no, it's not. It's, we thought we had it in there, but it turns out, it's missing or it's incorrect or it's outdated. So, this was actually sort of one of the unexpected benefits of having a chatbot is like, by looking at the wrong answers, it made us realize that there were holes in our documentation that we could then go and patch up. And so that was really nice. Sometimes the answer will be in the docs, and for some reason, our chatbot can't seem to find it. And in those situations, oftentimes the easiest solution is just, hard-code an answer. We have a set of hard-coded questions and answers that we send in to Bill that it will pull from the embeddings database. And this works, very well. Once you sort of put one of these in, it will get the question or get the answer right almost every time. But, you have to be careful because unlike your documentation where people are looking at it every day and they might notice if something gets out of date, you got to be careful that any internal FAQ, make sure that you are reviewing it on a regular basis and make sure this stays up to date because it's really easy to forget about this because only your bot is seeing it. Looked at a few other ways we could maybe try and make our chatbot smarter. More isn't always better. We thought, particularly these days, context windows are getting bigger, meaning you can shove more information at your chatbot. I'm getting a phone call. That's weird. You can, shove more information at your chatbot, and you're like, well, that's great. It'll get even smarter and smarter. I noticed that hasn't really been the case. What seems to happen is the more information you give, sort of oftentimes the less relevant the information gets. And if your bot feels compelled to like start answering, based on some of this other information, the answer quality is either the same or lower than before. And you're just paying more for it. So shoving more information doesn't always help. One thing that we did do was change the way that our bot reads in code. If you take this code through an embeddings model, it's not necessarily going to, know how to convert this, what the meaning is of this text beyond like, well, this seems to be, like some JavaScript code. What you really need to do is have a text description of, what this function does so that the embeddings model can sort of, interpret it based on that text description. And so that's what we did is like, we took all of our functions and we sent it to OpenAI and said, write a ridiculously verbose, description of what this function does. And then we take that description alongside the code, and that's what gets sent to our embeddings model, which then, converts it into something that is a little more likely then to get returned. We sort of saw that we do now get more of our sample code getting returned in our questions now that we started doing this. Of course, the drawback is like, this is all like my crappy sample code, so it has to be good. It's not yet. Another thing that we looked at is, can we change the way it parses reference documentation? An interesting thing about reference documentation is like, if you look at like this APR percentage, there's a lot of implied context around that entry, around that field. Like you have to see, oh, this is part of the credit APR's JSON object that's getting returned from the liabilities get endpoint. You would understand that if you were a user looking at our documentation. A chatbot might not necessarily get that. So one thing that we've tried is actually change the way our reference docs are displayed when they're being read in by our chatbot. We add in a lot more like kind of redundant information that hopefully will make it a little easier for a chatbot to understand. We've tried this. It's sort of been mixed results. I haven't seen a noticeable improvement, but I'm not giving up on this yet. My theory maybe is that like, one other issue is like there's, particularly in our reference documentation, there's a lot of different concepts that can be represented by that same chunk of information. And our embeddings model still has to distill it down to like one single vector. And so I think probably our next solution from here is to like, can we break up our reference documentation into smaller chunks? So that'll sort of be the next experiment that we try. But I'm going to say this, along with sort of a lot of our other like, different ways of interpreting the data and breaking it up and storing in the database and all of that. That's all on our list of stuff to try, but we are starting to see, I would say, diminishing returns. Like I said, it is kind of still a manual process of evaluating, the changes that you make and seeing if the chatbot is maybe getting better answers. And, you are sort of seeing like, I think the low-hanging fruit has been picked. And so, you're seeing diminishing returns. So a lot of these projects are still on my to-do list, but they've sort of been, I would say, relegated to like side projects or fun things that Todd does when, I'm not doing my real work. I would say what has still made the biggest impact is using the newer models. Newer AI models are getting you sort of better results and, having good source material in the first place. I have like 2 minutes left, so I'll talk real briefly about security concerns. Actually, Ruben touched on a lot of this already. One thing I would say is, assume that any information you fed to your chatbot can be seen verbatim by your customer, either by tricking your bot or, sometimes it just like prints out chunks of the prompt. I'm like, I didn't want you to say that, but it did. Now, for us, not a big deal. All of our documentation, it's all public information. But be careful if you start bringing in like internal FAQs that maybe include engineer names or code names or like due dates that you don't want to make public. Be careful. Don't feed that into your chatbot because again, a user could see it. Was there something else I'm going to say there? Maybe not. Jailbreaking, that's sort of another concern. This happened on Reddit a few months back, Reddit/Twitter/Threads, where people realized they could trick the Chevrolet of Watsonville bot into talking about stuff that had nothing to do with Chevys in Watsonville. It was kind of neat. I would say in terms of this kind of concern, like it's a moderate concern. Like there's not the same kind of monetary benefit of users doing this as like, mining Bitcoin. Like, yeah, you can kind of use, GPT-4 for free, but it's easier for people just to go to Bing and do it there. So, the biggest concern is sort of people do it kind of for fun. They do it, for shits and giggles, if I'm allowed to say that. And so, like, the two things you should kind of do here is one, rate limiting, because if you do end up on the front page of Reddit, you don't want that to eat up all of your, all of your OpenAI costs. And, make it clear to your users that they are talking to a bot. I think one, it's a little more honest. And two, it's less fun to jailbreak a bot that tells you right at the beginning that it's a bot. So I am out of time. You can go to kerp.blog because I wrote a few other topics around sort of a few things that I had to cut in the presentation for time. And, I could always use more readers on my blog. So I'll give you a moment to take a picture of that. And with that, I'll say thank you very much.
Thank you, Todd.